Amazing. Okay. Hey, everybody. It is Tuesday, February 28th, 2023. This is a meeting of the SIG Network Policy API subgroup SIG Network. We're here to talk about network policy and all the fun related things and work towards a better future. So let's follow the rules, be nice to each other, and let's get started today. So not too much on the agenda before we get rumbling. Akil, I think you're newer here. You want to just give a quick intro for everyone in the group?
Yeah, sure. Yeah, I've recently started contributing to various like Kubernetes networking projects. I work at Google on the data plane V2 team. Yes, pretty much it.
Sweet, thanks, Akil. And you kind of lead us into our first topic, which is an issue you opened regarding protocol being at a higher level than ports. So
yeah, maybe I can give a quick summary. So yeah, we were exploring using the sort of traffic selection components of admin network policy for like a completely unrelated use case. And so we thought that was a good place to start. And that's when we stumbled across this particular issue, because we were having trouble representing like traffic selection behavior, where really the user wants to define a rule concerning the IP protocol. So in like one specific example is ICMP, right? Being able to allow or deny ICMP traffic. I think that's a bit tricky to do in the current API because sort of the ports is sort of the top level field in the rule, and protocol is sort of a subfield of port number, or I think port range. And so it wasn't obvious how you would represent a rule such as, you know, all TCP port 8443 traffic and all ICMP. And I think this is just more relevant with IPv6 adoption, because ICMP is like a core part of IPv6, and I think it'll become like increasingly common that you'll want to define rules over over ICMP. And I noticed some of the other network policy implementations or network policy APIs already have custom like behavior around ICMP. There, ICMP is sort of a top level field. And so I'm wondering if, you know, either ICMP specifically or protocols themselves should have more like, I guess, priority in some sense over ports, like whether that API makes sense.
I had an unrelated question. Is ICMP supported for the API field?
Today, I don't remember. Let me go look.
Is it supported as a protocol? Was that the question?
Should be.
Yeah.
Right?
No.
I thought so too, right? It wasn't, so.
I added a comment to this bug right as the meeting was starting. Basically, like Kubernetes networking is only concerned with TCP, UDP, and SCTP, and nothing else is really well defined. You know, like the pod network itself may have rules about how ICMP is or is not transmitted. So this is actually a bigger question than what the filer said. It's basically just completely undefined.
So this is a like very valid use case. So I feel like, especially like I actually had someone ask me about this a week or two ago. So it was perfect timing. Akil, thanks for opening this. Is this a place, Dan, you think we can start to define that in terms of policy? Or do you think because we don't reference ICMP explicitly anywhere else, there could be a lot of CNIs who are like, we can't do this? What do you think?
So there will certainly be network plugins that would not be able to implement things that we come up with here about ICMP or other lower level protocols, which might mean that we would have to, figure out some sort of status, whatever, for the implementation indicating whether or not it could implement that feature if we were going to add it. But backing up, you say that there are good use cases for this. And if that's true, why were they not in the document? So I'm going to push back on that. The fact that other people are doing it does not necessarily mean that there are good use cases for having it in admin network policy. And I'm not saying that there aren't, but we should come up with what the use cases are and then think about how and if we would implement them.
Agreed. Yeah, I think they should start from use cases. If anything, it was just never that detail was never brought up when we discussed use cases explicitly. I think this issue is kind of a good start at it, right? It's less of a use case, more of a problem. But I definitely think it is a problem.
I think can you hear me?
Yep.
I think I just saw a kind of use case for that. I don't know too many details, so I can try to dig into that a bit more. But there is a customer that is trying to do the health checks, I guess, between namespaces, and everything else should be denied for all these namespaces, but they want to allow ICMP only because that's how their health checks work. So there may be a better way to implement that. I'm not sure. I can try to figure out some details if you can guide me with some questions we may need to answer for that use case.
So with network policy, it's totally vague what happens with ICMP and like ARP and other protocols when you have a network policy in place. I don't know for sure what OVA and Kubernetes does. I know that in OpenShift SDN, it's like totally deranged, where like if you isolate a pod and then say that another pod IP can access it, then it will allow ICMP. But if you only allow access on a particular port, it won't allow ICMP. And that's not even like intentional. It's just like a side effect of these rules that were written without any thought for how, what we should be doing about ICMP. So we should probably we should definitely have clearer rules about, should this even if we don't have explicit ways for adding ICMP support, we should say whether the rules are expected to affect ICMP or not.
Yeah, that's right. I mean, does the use case sound like reasonable at all?
Well, okay. So the reason I was thinking about this when you said that is because, maybe network policy should just never block ICMP anyway, right? So in which case, they don't need a special rule for it.
But that is not really safe, right? Then someone can just sniffle the piece or something.
Maybe.
I mean, it depends on the use case, right, Nadia? Like if we could come up with a use case that says like not blocking ICMP leads to a really insecure scenario, it makes sense. For health checking, is that like a security use case or more of a functionality use case? Like, why would we ever want to, I guess what Dan's trying to say is like, why would we ever want to block health checks?
Is
there a use case for that?
Block the health checks. We can either just always allow, as Dan just said, ICMP, right? Or if not, then define how exactly it will be dropped, right? And probably always allow is not that safe, right? Then we need to define if it can be dropped by the network policy, let's say, or if it can be allowed for the ICMP specifically.
I think in the immediate, it's an important point. We're missing our documentation. We should have a note somewhere that says like, today we ignore ICMP, and for the implementers, like ICMP should always be allowed. But in the future, we can analyze a use case for selecting ICMP and dropping it or allowing it explicitly. I think those are kind of the two actions.
But Nadia is right. It's not at all clear that ICMP is always allowed is actually the right answer, as opposed to ICMP is always blocked. Or
yeah. Okay.
Yeah, but also if I'm using large packets, I don't need the need frag. For that, I need ICMP. So explicitly wanting a rule that says you need to allow ICMP in addition to UDP or whatever, that is something the user might not expect to do. So
yeah, that's another good point. We should always, the network should always allow packets that are needed to allow the network to work. And ARP is another good example of that, right? Like just because a pod is, well, I guess only the pods that need to be able to talk to it need to be able to get its ARP. But like, but yeah, stuff like needs frag needs to be automatically allowed if it's relevant.
yeah. It's related traffic at the end of the day, part of an existing connection. So I don't know if you should be like having a rule that allows it.
So that was that was the exact use case that we ran into, needs frag, like defining, basically allowing those specific ICMPs and blocking all other ICMP packets. That was our specific use case.
So why would you want to block all other ICMP packets in that case, Akhil?
So it's more like we really, ICMP echo like provides no value for, so it's just like minimizing the surface area, for instance. There's no real reason why we want the pod to be able to probed arbitrarily by any other client in the network. Maybe we need to dig into it deeper and find out if that's really a risk, but just our initial thoughts were block unnecessary ICMP types. But yeah.
I mean, could it be a risk? This is a question that I have no idea about. Maybe someone does here. Can you like flood an interface with ICMP echo requests? Like say you're an attacker and you like send 1 million ICMP echo requests to an interface, like are you going to overwhelm the system?
I think the concern is more around some ICMP packets you expect a response from. So it allows you to maybe saturate the link or even probe the detection of a pod. Again, maybe on a local network, none of these are actual risks. So I'll have to like investigate more. It was just our initial instinct was, hey, we probably shouldn't allow it, but yeah, it's worth digging into.
Cool. Well, again, thanks for opening this issue. I think you definitely poked a hole in something we missed. I think continuing the conversation on this issue is great, but then also like turning it into a piece of documentation, at least for what we have now, and then using it to drive any further use cases for like our V1 Alpha 2 discussion would be the way to go. Nadia, you said you were interested in helping out here. Like, do you think you could maybe kind of document any use cases you have so far in that issue and we can roll from there?
Yeah, I think I can. So just to sum up, for now, the behavior for all the protocols not listed basically in our docs is undefined, right? And then we can start from that. We probably cannot cover all the possible protocols anyway, so we can just start by defining behavior for some additional protocols like ICMP or something like that, and making it optional for plugins to implement. That's like the general approach.
I think a good starting point to go from is what Dan was saying. Like we shouldn't, any undefined behavior shouldn't break core functionality. So like if we can make sure that we define things that aren't going to break like standard functionality of the data plane, like that would be great. Or have some note in the docs for that, because we definitely don't have anything. That's a really good point.
Yeah, I mean, since now it is undefined, anything we say, like any rule we define there, right? That may break some networking plugin, for example, because it was undefined before and it may not work as we
Right. It
define
was
later.
undefined, and one CNI may implement it differently than the others, so that they make sure their things are going to function for their use case. But it'd be definitely easier if we could define some sort of catch-all for now. But yeah, so I think step one is just define, like, or maybe put a note on it in our documentation, and step two would be starting to look at if there's use cases we can bring up for V1 Alpha 2 that go around this.
Yeah, I think I can do that.
Yeah, and also while we're here, Nadia, I didn't see you on my meeting list, but you're also new here. Do you want to give everyone just kind of a quick intro as well before we hop on to the next thing?
Well, I work for Red Hat on OpenShift networking, so that's kind of all you need to know about me, probably.
Awesome, cool. Well, thanks for coming here, and we need your help, so really appreciate it. Okay, is there anything?
Yeah,
Sorry, go ahead.
so on a related note, since we brought up this issue, I'm also thinking about, like, when we designed the AMP, did we agree on the use case where we wanted to define the rule where it's between maybe up one sort of pod and the other, and we only wanted to allow TCP connections in between these pods, rather than other protocols such as UDP or whatever other protocols. How do we actually define the rule like that? I would imagine that for the current APIs, as Tim suggested at some point, we were needed to use a port range and list the entire TCP port range out explicitly, saying I want to allow these as the entire TCP connections, and then have a deny rule which says everything else will be denied. Is that how it's supposed to be written as of now? I'm just wondering this because I mean, even for the protocols that we do support right now, it's not straightforward to write a policy saying that I only want to allow one specific protocol as well, I think.
Do you actually have a use case for that? Or are you just talking about it because network policy does it?
So, sorry, you mean network policy actually does it? No, right?
Yeah, so you can do that in network policy, but it always seemed to me like a really weird, like, network policy has this problem that people basically wanted every possible combination of tokens to be a valid network policy. And so you end up with these things like allow all TCP connections, but no UDP connections. And like, I don't think anybody ever actually suggested a use case for that.
I see.
So I'm not that worried. And in fact, given that, as you said, you can just do a port range from 1 to 65535. If somebody really needs it, then it is there.
Right, like that's what I was going to say. I think you can express it between, like, doing a default deny all baseline admin network policy with the port range in the admin network policy. You could do something like that, right?
Okay, yeah, makes sense.
Cool. Okay. The next thing we had on the agenda was, I just wanted to touch base on this PR because it is really important. Thanks for opening it. Basically, for anyone who's not here, we didn't have a generated client step for our API, so it was hard for users to actually interact with it. So Yang kind of came in here and started doing that. Do you need any help here, Yang? I think we figured out the verifier, and then I had like one comment, but otherwise it looked good.
Yeah, I still need to look at this because I didn't see it yesterday. So yeah.
Okay, no worries.
Oh, it's about the vendor package, right? Yeah, it was a little bit tricky because I was going to write the scripts without the vendor the vendor package, but I do saw that one of the things that I saw, I think it's even some repository inside Red Hat that uses, you know, the vendor directory and call the script in there, because, you know, the generate group script was so well written, you can just use one single script to generate everything that you ever needed. Whereas if you put in things like in the make file, you have to write a couple of them, you know, on your own. So I just thought there will be a quick hack to use that well-written script and have everything generated in one place. So, but I can definitely change it to the other way around though.
Yeah, no, that makes sense. I just personally don't like calling a script in the vendor directory. I would rather use go run kind of like manually to generate the client set informers and listers like individually. So then if there's a problem, it should be easier to debug like one individual step. I kind of got this from the Gateway API, so I didn't know a lot about it beforehand, but I had to do something similar recently. So
no worries. Yeah, I'll see if it's it should be pretty straightforward to change it that way as well. And hopefully it doesn't really affect any of the generated code. It should not, ideally, right?
Yeah,
that should be the point. Yeah.
And the only other thing I didn't get to look at, did you add to our actions or to our CI like a verification to make sure that on a given PR, all the generated code is correct?
Oh, I
like
don't,
a verification.
yeah, that's a good point. Yeah, I should yeah, I should I think there's already a check code gen in the repo, right? But I just don't know if it actually checks for the
It doesn't check. It definitely wouldn't. Yeah, there is, and it wouldn't check for the
thing that I added.
right, for the client set informers and listers.
Yeah, I'll look into it and make it part of the PR as well.
Sweet, that'd be awesome. And if you go to that link, I just had to do the same thing, so you can kind of see there. And if you need more examples, check out the Gateway API. They did a really good job.
Okay, cool.
Sweet. Amazing. Thanks, Yang. That's an annoying little task, but it's going to be really helpful for our users. I kind of a previous note on that, like on a different repo, I was going to try to avoid maintaining client sets and just telling users to use a dynamic client Go package. But that was kind of ugly. So I think maintaining client set is the right call. Cool. Okay, last thing on the agenda for today. Good point, Shane. We need to update everything to the new Kubernetes image repository. I don't even know if we have anything pointing to the old one, but we'll have to do an audit on that for sure.
Yep. And anything like downstream you guys got going to, make sure you'll want to switch those over. It's just kind of like a PSA. I figured it might be redundant for a lot of people here, but
it's mostly EDE tests that need to worry about and install stuff, I guess, right?
Yeah, that's for the most part. Yeah. Like if you're using core DNS from GCR.io anywhere for some reason, you know, in some random test or something, switch it over to registry.ks.io.
I feel like if anything, we'd be using the agnostic image that was upstream for a long time. We use that all over OpenShift. So cool.
Sorry for being late.
Oh, no worries, Per. How's it going? Okay, and then there was one other thing. I know, Nadia, offline, you and I had talked about another issue you found with our API. Did you get a second to make an issue for that, or are you planning on doing it, or do you need someone else to do it?
I think that's also docs update, right? So I probably will try to do that together with this ICMP behavior documentation.
Amazing. Cool. Okay, does anyone have anything else for today? I think we have some good action items. Thanks again, Akil. Like, this is awesome. This is what we need. Are there any updates from Yang or Surya on like implementations, or just chugging right along there?
Yeah, I think we're making good progress with the implementation on OV and Kubernetes. So actually, thanks Yang for the client set PR, that ClientGen PR that you have. So just consuming it, and I think we're on track. Let's hope that we have a prototype that we can use for our end-to-end testing in CI soon.
Yeah, that's actually really good to know. And I do have a related question on that regard. I think on the Entrea side, we are also trying to, implement the AMP. And that's why, when we run into the client set problem. And I think one of the things that we are, I heard that we are actually running into a little of trouble is that, for the, let's say, the not self or the not same labels implementations in Entrea, because in AMP, obviously, we decided that we don't want the AMP to affect the not self traffic, right? So essentially for not self, when we select some sort of like namespaces, the effective semantics of that selector will be everything in the cluster except for that namespace. So I'm just wondering, in Oven Kubernetes, is there any sort of like difficulties or other things that you encountered or imagine would encounter in implementing a semantic like that, or you think it should be fine in Oven Kubernetes?
No, that's actually a great question. Yeah. The answer I have for you now is we are just starting off with East-West.
Okay.
So the ingress and egress with north-south is not yet on the horizon. So let's also keep in sync, and I will talk more when we start with that.
And Surya, I think it should be a little easy. I think what Yang was saying, like, is it going to be easy for Oven Kubernetes to implement only looking at East-West? And I could be wrong, Surya, so correct me, but it should be a little easier because once traffic enters into the overlay with Oven Kubernetes, like, you're in the overlay, like you're in the cluster network once your traffic has made it in there. And so it should be easier just to focus on East-West there. Am I right in saying that?
That's think, true, actually.
I think one of the problem I think we encounter is that, if a pod initiates a traffic, and in the end, the destination is actually, let's say, out of the cluster. Let's say we're enforcing the egress rule. I think in Entrea, it's a little bit tricky to sort of like know it at the beginning or the egress enforcement level, because it has no idea on whether this corresponds to a destination that's on another node or it's actually cluster external. So that's, I think, the thing that we are actually running into a little bit trouble.
Yeah. The classification of the destination is tricky.
Well, if it's in Antria, is there a concept of like a dedicated pod subnet? Can't you just say if dest is pod subnet?
Well, for local environment, I shouldn't say local environment. For normal use cases, yes, but not on public clouds.
Even on public cloud, say you have two nodes, right? And pod on node A, pod on node B, same subnet, right?
Well, in public clouds, a lot of times this is information that's opaque to the CNI, actually. So.
But the CNI is managing the pod network. So how are the pod IPs? I'm just trying to understand, how are the pod IPs opaque? I get like maybe the node IPs being opaque.
No. It's in public clouds, in the mode that Entrea actually runs, the public clouds actually manage IPAM for the pod IPs. So what Entrea runs is a mode that's called non-in-cap, meaning that it doesn't really do the IPAM and everything, for the pods. It's just a CNI that, implements connectivity as well as network policy. So when you know, I think it's more like a idea of like a chained CNI, because let's say on the EKS they have a primary ENI, which does, you know, assigning pod IPs and stuff. So Entria works sort of like hand in hand with it, where we let the EKS ENI do their thing about, you know, pod spin up and tear down and everything. And after that, you know, Entria does the connectivity and network policy bits. So right now we don't have a sort of like good way to communicate with EKS and say, hey, can you just give me the, you know, entire parsider of the cluster so that we can do a couple of things. We don't have the mechanism like that as of now. I mean, that can be one solution to this, but it's going to be tricky, because if that is the case, I remember that it is also a property that EKS users or the public cloud users can actually config, right? They can sort of like manually change the pod sider they wanted to assign to a specific cluster, because it's in their own VPC. So when that happens, Entria or other CNIs may need it to sort of like watch for those changes and updates, you know, its underlying implementation. Say, hey, right now, you know, the entire cluster doesn't mean this cider anymore. It means a bigger cider or a smaller cider. So this is probably a route that we didn't really want to go into. But anyway, I do realize it can be implementation specific, definitely, because if we are using some sort of like label based matching for network policy, and this should be sort of like a little bit easier, because you can just look for a specific label or something like that to understand, hey, this is coming from, you know, inside of the cluster rather than out of it. But for egress, I still think it's a little bit tricky, because, you know, you don't know where you don't know what that destination address actually is, right? So
cool.
So one of the arguments for having the, you know, only applies to east-west, not to north-south, was that you can end up with policies that do the same thing in network policy, because if you have just an empty namespace selector as the selector of a policy,
yes,
then that selects all pods. So is that also difficult for you to implement in Entria, or?
No, it was not difficult. It was just not efficient, right? So essentially in that case, we just pop all the pod addresses there.
Okay. So anyway, but yeah, so I was saying, like, that was part of the argument. Well, they already have to be able to do it, so therefore we can do that. If it turns out that, like, you know, the use cases are different enough that it's okay to have that in network policy, but it would be painful to have an admin network policy, then maybe we should revisit that.
Yeah, that's why I'm trying to bring this up and see, you know, if everyone else encountered this problem, because I see Per had a hand up. Sorry.
No, it's like it's the same. I mean, we discussed multi-networking before, right? This is when it gets really, really iffy with multi-networking. That's really to understand if something is in cluster or which node, or if it's leaving. That's when it starts to. It has the potentially to explode and become really, really expensive to do the filters.
Right. I think the problem is, you know, I agree with the argument. It's just that, you know, when we're doing the network policy implementation to implement, let's say, the namespace selector empty curly braces, we just pop all the pod addresses in there, and it's not as bad. Whereas when we have the not self selector now, for example, let's imagine that we have a policy that selects all the namespaces, right? And say for each namespaces, that's compute not self. Now the problem becomes like a n square worse problem.
Absolutely. You don't want to have to know all the potential in cluster destination addresses. You just don't want to know it. And if you don't have a way to classify if a packet is in cluster, I mean, destination is in cluster, or even better, which node it is, that's what you end up with. Or you have to build your policy implementation in such a way that you can sort of by following the routing know that you will end up at some point of your firewall, and from where you ended up can draw conclusions. It has the possibility to become really, really expensive. I mean, especially if you do, I mean, currently if you use one L2 that can connect to pods on every node, and even on stuff that's outside the cluster and has its own IPAM, like it's going to be challenging, so to speak, to do that. It's really easy to write the policies, right? I mean, you just say label set in reality and label set, but the cost to implement it will be high. And I think the multi-network, I mean, I'm in the multi-network group too, but I don't think we look at those things, especially not when we look at topologies. It's like it just gets pushed over to this group.
Yeah, Nadia, you want to say something?
I have a question, maybe, Steve, that the host network pods are supposed to be affected by that?
In Ensure, I can only speak for Ensure. It does not.
But is there something in the documentation for ANP about that?
I don't know about how network policy actually treats that. But I would also imagine it does not, for, let's say, if we select a ingress or egress peer, it would not actually include host network pods, if my understanding was correct.
Yeah, that's correct. And it's not really documented anywhere for either network policy or admin network policy.
So
I think one of the reason is that, for the IP based solutions, obviously, if you actually include the host network pods, then you basically just put the node IPs into the ingress and egress peer that you enforcing policy on, and it really makes the node pod traffic and stuff like that really, really messy if we actually include the host network pods into the rules. And it's not really correct in terms of traffic enforcement as well. So because if you put the address in there, it affects maybe other host network pods that doesn't really match the label selectors, but happen to share the same address, if that makes sense.
Yeah, exactly. That's how kind of how it works, in Kubernetes also. But I mean, that means that admin network policy cannot really be applied to host network pods. And I would say there is like a popular request to allow IPS server pods or something like that.
Yeah. I totally agree. Yes.
And also, I'm not sure, but I think in Kubernetes will have like a similar problem with defining what is east-west traffic.
I know the current API, right? Like for ANP, we are completely going with selectors, right? And if I look at the way the types is written currently, it just says in cluster peer. So that's what I think the current KEP defines it as. So we might want to broaden that, right?
Yes, I think that the reason why I'm bringing this up isn't that we can't realize this, like we can't implement this. It's just not going to be efficient, if I'm making sense. Because let's say if we have a cluster with 100 namespaces, and there is actually a AMP saying that for each of these namespaces, I wanted to drop not self namespace traffic, right? So by the end of the day, if you do it by brute force, obviously you can do it, right? You just have a rule for each of these namespaces and put all other namespaces IPs in the rule saying that, hey, I want to drop these. We gotta be able to implement that, but it's going to be really, really not efficient. It's not going to scale well at all. So it's definitely a challenge in CNIs to sort of like find a way to implement this correctly, I would say.
Yeah, there may even be a problem with the correctness in general, because you basically need to explicitly ignore everything that is not internal destination, let's say, and you like when a new when like the definition of internal destination changes, if there is like a new CIDR or something, there may be some delay in updating that, especially if like network policy managing plugin doesn't know anything about that. Yeah.
The brutal truth is that whenever anything grows, especially we have a lot of addresses, any firewall that compares addresses will become inefficient. And the more things you have to change just to keep it updated, which address is used for what, right? So as long as the firewall basically compare if if addresses belongs to two sets, it's going to be very inefficient. The larger the clusters we go, when we heard numbers from Google, right, 15,000 nodes, obviously that will generate enormous amount of addresses.
Yeah, but I'm also saying, so now for network policy, it kind of should ensure before setting pod status to ready, right? Before saying that the networking for the pod is ready, it should make sure that all deny rules for network policy are set. So pod should not be able to access with just the network policy definition. Pod should not be able to access any denied resources since it is created. And then if we consider like pods that may be managed by something else, that is not the case anymore. So I mean, at which network policy needs to be set up for the pod at some specific life cycle stage of the pod, right? Because you cannot just apply that randomly after, like in 10 minutes after the pod was created.
Well, you technically can, right? Like, because right now it doesn't really require you to have a network policy in place before the pod is created. You can technically create a network policy that applies onto the pod 10 minutes after the pod is up, and we just expect the CNIs to take whatever delay it takes to actually implement the network policy, maybe in like 0.01 seconds or something, and then boom, it comes into place. And
yeah, I think I'm actually about to add docs to the network policy, saying we've discussed that with Dan, that actually deny rules should be in place. So in general, based on common sense, if the network policy is applied and then a pod is created that is selected by the network policy, it shouldn't be able to access any denied endpoints at any point of its life cycle, but the allow rules may come later.
But I mean, you should say existing network policies in that space, right? It's like if the policy is created, you can only talk about this set of policies that are already known. And,
Yeah.
and I would say that when it comes to anything that transforms things into addresses for its implementation, especially on the sort of both egress and ingress, you can have, the number of pods that you can access or you can be accessed by is a changing set. And if that's changing quick enough or fast enough, you will never know. Sort of.
Well, that takes us all the way back to the status and why it wasn't.
Well,
really
exactly. It's
implementable.
sort of the way this is done
Really tricky.
to have stability in the rules. The way most most implementations are done, when both the source and destination address needs to be known and mapped at the source pod. If a large system, this will never be stable. Basically, you need to have a distributed firewall to have this stable, so that it's on the receiving side that the final check is done. And we need to build implementations that only cares about the addresses on each node and not addresses on other nodes. This is not easy to do, but that's where
Yeah.
it needs to go to become stable for really large implementations.
Well, we've delved into a lot of I think implementation specific issues today,
absolutely.
right? And I think like it is important because we can't design an API that makes absolutely no sense to implement, right? Because no one's going to use it. But at the same time, like maybe, I mean, network policy was kind of implemented in a million different ways, right? And there's a lot of different
And it should
problems with it. Yeah, and it has to be. But I think we're in a unique position to kind of see what's possible and then create like a continuous feedback loop to the API to say, okay, we tried this, it didn't work. So like Yang, if you could just take the problem you're running into and maybe throw it in that issue just so we have it documented, I think it would be great for our next iteration. So
Yeah, sure.
Also, the comment from Dan that's in the chat, right? Wanted to get a bit of clarity on that one. Like, have the plugin have a rule that is okay to get confused with some IPs that are near, even if they aren't really?
So yeah, like the problem here is that because the cloud is the one assigning pod IPs, so the network plugin doesn't know the complete set of IPs it might be using, but it knows roughly what the local subnet is, and so we could just say, okay, you're allowed to just pretend that that entire subnet consists of pod IPs, even though some of them might actually be node IPs or other things in the cloud, and possibly like that would end up working as an implementation.
Should we sort of specify? So I mean, we could specify, call it classifier rule, right? And if you give it an address and if it's within these scopes, you come back with the classification that it's cluster local and so on. When just put it, because that's what you're asking for, right? You take a destination address and you want to know if it's should be considered under the ingress and egress rule towards other pods, and not sort of an address that's on the net. So it would help, because then we could push up all the way up to when people do for multi-networking and say that, well, you need to put the classification here. Addresses on this network, can they be considered to be local? And sort of back with IPAM. I like that idea.
Yeah. I think that's a good starting point, at least, right? Like, it's better than having something that's not defined at all and something we can work with.
yeah, having a note on scenarios where the CNI isn't in direct control of the pod subnet or doesn't have an explicit pod subnet, like I think that's really important. So if we could add like a bit to that issue and maybe even find a place to put a note in the docs, I think that'd be a good start.
I have also a question. So some of the things like host network pods should be subject to network policy and admin network policy, and also some notes about the protocol that is also related to the Kubernetes network policy we have now. So do we also want to try and update that documentation, like together with admin network policy?
You mean existing documentation? I think there's no negative to that, right? That'd be awesome. Like, I think that would definitely fall under this group, right? We're working on AMP a lot, but we're also kind of here to help out folks with network policy. So updating the existing docs would be awesome.
Yeah, to be honest, I think I remember a while ago when somebody opened an issue saying that, hey, why Entred doesn't actually select host network pods. I remember what the dev team in Entred did was actually interestingly deploy CDM and Catchall and see if their network policies actually select host network pods, just to verify that we are having the same behavior. So I guess that really, says to the documentation on, the network policy API documentation doesn't really say anything about that. So it's basically up to the implementations, and I don't feel like there are ET test cases covering those two.
That's another thing I was thinking. Maybe we need E2E's test case to prove that they don't today, if that's what we put in the docs, right? So I know OpenShift doesn't affect host network pods either with network policy. So maybe we're all doing the same thing just by pure, it's really hard to implement, right? So.
And we're asked the same about the life cycle of the pod from the point of when network policy rules should be applied to a newly created pod. So that's also quite confusing for customers, I think. But
I don't know if we can spec that out in the API, right? Like if we in admin network policy would say like a pod can't be created until network policy is implemented, wouldn't that involve a change to the pod API as well? Like that's a bigger topic, I think.
Yeah,
No.
that is.
It's that the network plugin can't claim success in setting up the pod until it's isolated. So the pod object can be created. It just, the resources can't be.
You just need to define, like, it only applies to the existing network policies, right? So when the pod is started, and the network policy is created after that, you probably don't need to wait for it to be applied. So then you need to define what existing network policy related to the pod object means. So do we want to compare like creation timestamps or something?
Again, if we're not reporting, or if not providing a mechanism to report that in the API, like, is it our role to define that flow in the API? I don't know. I'm a little confused on that one. I see the problem, but I don't know how, if that's a problem we solve here, or if that's a problem that needs to be solved in the implementation, or if that's a problem that needs to be solved maybe in like CNI,
Yeah, that's a status related network policy discussion again, so.
Right. Okay, anything else? Some really good conversation today. Thanks, everybody. If we could just kind of update the issues with what we've talked about today, or I know specifically around the explicit protocol one and the east-west traffic one, that would be really great. Is there anything else folks want to talk about before we finish up?
The east-west traffic one that Yang brought up, do you think it needs a new issue? The other one seems a bit more wider, just support for egress.
I was thinking about that too. I think why not make a new issue, because implementability of just east-west was a concern in the CAP. So I think it warrants a new issue if that works for you, Yang.
Yeah, that will.
And then we might also need a new issue pertaining to host network pods. Cool.
Yeah, I think I can do that.
Okay, go ahead.
Cool, thank you.
Yeah, I was thinking to do that for the network policy documentation also, as we've discussed. So.
Amazing. Cool. Well, on that note, really great conversation today. Thank you so much, everyone. And yeah, I'll look forward to seeing some of the updates and the issues, and we'll just keep chugging along. And if I don't see you soon, I'll see you in 2 weeks. So thanks, everyone. Hope you have a really good day, and we'll talk to you soon.
Take care. Bye.
Thank you. Bye.